Okay.
So this seemingly complicated formula can actually be applied to some problems that will be really helpful. So let's have an example. Our first example will just be the antiderivative of two functions because we are essentially undoing the product rule. So we need two functions. The first function will be, let's say, sine of x times x, dx of course, and this represents this part here. However, the trickiest part of this is deciding which is which. Is sine of x f of x or g prime of x? Well, let's try each out. So if we make x equal f of x, then we will be taking the derivative later on, which will be much easier. The derivative of x simply equals 1, but instead if we assign it the role of g prime of x, we will be taking the antiderivative of that, and we'll get something much more complicated like x prime over 2. And we don't want that. We much rather have the derivative of x equaling 1. So instead, we will assign the role of g prime of x to sine x and the role of f of x to x. So using that, if f of x equals x in this equation, and sine of x is g prime of x equals sine x, then it becomes much simpler to use this formula. So just rewriting this out in much nicer form. The antiderivative of sine x times x dx equals f of x, which we have said is x, times g of x, which is actually the antiderivative of g prime of x, and the antiderivative of sine of x is negative cosine x, minus the integral of f prime of x, which we have said is 1, simply, is the derivative of x, excuse me, and g of x, which is the antiderivative of g prime of x, once again, is simply negative cosine x, and this can now be rewritten to the final form, which is sine of x, x dx equals x times the negative cosine of x minus the integral of negative cosine of x, which in the end is negative sine x. So instead we can just make that addition, sine x. And this is your final answer, which we got by using the integration by parts formula as Olivia stated above.